In the present video, we will solve the assignment problem by Hungarian method. Let's see the problem. Solve the following assignment problem using Hungarian method. The matrix entries represent the machining cost in rupees. Here given the number of jobs in rows, which are the 5, and number of operators in column, which are the 5. So number of rows are equal to the number of columns. Then given problem is balanced assignment problem. Now apply the Hungarian method to get the optimal solution. And we can apply this Hungarian method in two phases. Phase 1 is, there are the two steps. Step 1 is subtract the minimum value of each row from the entries of that row. Second step is subtract the minimum value of each column from the entries of that column. So first we will solve the first step in the phase 1, that is the subtract the minimum value of each row from the entries of that row. So in this regard, first we have to find the minimum value of the each row. So in the first row, minimum value is the 8. In the second row, minimum value is the 7. Third row, minimum value is the 7. Fourth row, minimum value is the 10. And in the fifth row, minimum value is the 8. So next we have to subtract this minimum value of each row from the entries of that row. Now write down the new table. For the first row, subtract the 8 from all the elements. Then first row will become the 10 minus 8, which is equal to the 2. 12 minus 8, which is equal to the 4. And 15 minus 8, which is equal to 7. 12 minus 8 equal to 4. 8 minus 8, which is equal to the 0. Similarly, in the second row, we have to subtract the 7 from the all the elements. Then second row elements will become the 7 minus 7 equal to the 0. 16 minus 7, which is equal to 9. 14 minus 7 equal to 7. 14 minus 7 equal to the 7. 11 minus 7, which is equal to the 4. And third row elements, we have to subtract the 7 value from all the elements, and third row elements will become the 13 minus 7 equal to 6. 14 minus 7 equal to the 7. 7 minus 7, 0. 9 minus 7, 2. 9 minus 7 equal to the 2. And fourth row elements become the 12 minus 10 equal to the 2. 10 minus 10, 0. 11 minus 10, 1. And 13 minus 10, 3. 10 minus 10 equal to the 0. Similarly, fifth row elements, we have to subtract the 8. Then fifth row elements become the 8 minus 8 equal to 0. 13 minus 8 equal to the 5. 15 minus 8 equal to 7. 11 minus 8, 3. 15 minus 8, 7. So this is the first step in the phase 1. Next I have to go for the second step. Second step is subtract the minimum value of each column from the entries of that column. In this regard, first I have to find the minimum values from the each column. In the first column, minimum value is 0. Second column, minimum value is the 0. Third column, minimum value is 0. Fourth column, minimum value is 2. And in the fifth column, minimum value is the 0. So next we have to subtract this minimum value from the each column. In this regard, we have to write down the another new tabular column. Then first column elements are the same because we have to subtract the 0. Then so first column elements are the 2, 0, 6, 2, 0. Similarly, Second column and third column elements also it will be not change because we have to subtract the 0. So second column elements are the 49705. Third column elements are the 77017. And in the fourth column we have to subtract the 2 from the all the elements. Then fourth column elements are the 4 minus 2 equal to 2 and 7 minus 2 5, 2 minus 2 0, 3 minus 2 1 and 3 minus 2 1. And fifth column elements also it will be not change because its minimum value is 0. We will get the same values if you subtract the 0. Then fifth column elements are the 0 4 2 0 7. This is the tabular column after the phase 1 in Hungarian method. Now we apply the phase 2, that is the optimization of the problem. So in the phase 2, step 1 is draw a minimum number of lines to cover all the zeros of the matrix. In this regard, step 1, first we have to go for the row scanning. In the row scanning, mark a square around that 0 entry and draw a vertical line through that 0. If the row is having the more than one 0, we have to skip the respected row. So first I have to apply the row scanning. So first I have to go for the first row. In the first row, there is only one 0. Then you have to mark a square around that 0 and you have to draw a vertical line. So next we will move to the second row. In the second row also there is only one 0. Then we have to mark a square around that 0 and we have to draw a vertical line. In the third row, there are the two zeros are there. Then we are not applying the row scanning for the third row. We have to skip the third row. So next in the fourth row, there is only one 0. We have to mark a square around that 0 and draw a vertical line. In the fifth row, there is no zeros. We have to skip the row scanning for the fifth row. So now we completed the row scanning for the all the rows. After scanning last row, check whether all the zeros are covered with lines. If yes, go to step 2. Otherwise, do the column scanning. Here, after the scanning of the fifth row, still there are the two zeros are not covered with the square mark. Then I have to go for the column scanning. Column scanning, mark a square around that 0 entry and draw a horizontal line passing through that 0. If column is having more than one 0, have to skip the respected column. So in the first column, already we are removed by the row scanning. Second row also we are removed. And in the third column, so there is only one 0. Then you have to mark a square around that 0 and draw a horizontal line. And in the fourth column, there are the no zeros. We have to skip the fourth column. And fifth column, already we are removed in the row scanning. So now column scanning also completed. After scanning last column, check whether all the zeros are covered with the lines. Here, all the zeros are covered with the lines. So next we have to go for the step 2. Step 2 is the check whether the number of square marked is equal to the number of rows of the matrix. So here, so number of square marked are the 1, 2, 3 and 4 and number of rows are the 5. So number of square marked zeros are not equal to the number of rows. Then I have to go for the step 3. In the step 3, first we have to identify the minimum value of the undeleted cell value. So these are the undeleted cell values. Among these values, minimum value is the 1. So minimum value of the undeleted cell is the 1. Then add this minimum undeleted cell value at the intersection points of the present matrix. So here, so these are the cells are the intersection cells. Respected cell values we have to add the plus 1. So now intersection cell values will become the 6 plus 1, 7, 7 plus 1, 8 and 2 plus 1 equal to the 3. Next in the step 3, subtract the minimum undeleted cell value at the undeleted cell values. So now we have to subtract the 1 from the all the undeleted cell values. Then undeleted cell values will become the 7 minus 1 equal to the 6, 2 minus 1 equal to the 1, 7 minus 1, 6, 5 minus 1, 4, 1 minus 1, 0, 1 minus 1, 0, 7 minus 1, 6, 1 minus 1, 0. Next, all other entries remain the same. So now no need to change the remaining values. So this is the tabular column after completion of the step 3. Next we will go for the step 4, that is the go to step 1. So step 1 is the draw a minimum number of lines to cover all the zeros of the matrix. In the step 1, first I have to go for the row scanning. So in the first row there is only one 0. Then I have to mark a square around that 0 and to draw the vertical line. In the second row also there is the only one 0. Then mark a square around that 0 and to draw a vertical line. In the third row there are the two zeros. We have to skip the third row. And fourth row also there are the three zeros. So I have to skip the fourth row also. In the fifth row there is only one 0. So I have to mark a square and to draw a vertical line. So now after scanning last row, check whether all the zeros are covered with the lines. If yes, go to the next step. Otherwise I have to go for this column scanning. After the fifth row scanning, still there are the zeros are not covered with the lines. Then I have to go for the column scanning. So first we'll go for the column scanning of the first column. So first column already removed by row scanning. In the second column, there are the only one 0. Then mark a square around that 0 and to draw a horizontal line. And in the third column, there is only one 0. So I have to mark a square around that 0 and to draw a horizontal line. And so fourth column and fifth column, we are removed in row scanning. So now completed the column scanning. After scanning last column, check whether all the zeros covered with the lines. Here, all the zeros are covered with the lines. And here number of square marked are the 1, 2, 3, 4, 5. So which is equal to the number of rows of the matrix. Then we got the optimal solution. Then I have to go for the step 5. Step 5 is the treat the solution as marked by the square. So this is the matrix after the applying the Hungarian method, and this is the given problem. So now optimal cost of assignment is the, so we are assigned the first job for the first operator and cost is the 8. Similarly, second job is assigned to the first operator and cost is the 7. And third job is assigned for the third operator. So third job and third operator and cost is the 7. And fourth job is assigned for the second operator and cost is the 10. And in the fifth job is assigned for the fourth operator and cost is the 11. So now optimal assignment is the job 1 for the operator 5, job 2 is for the operator 1, job 3 for the operator 3, job 4 for operator 2, and job 5 is for the operator 4. Then total optimal cost is the 8 plus 7 plus 7 plus 10 plus 11, which is equal to the 43. So this is the solution, and thank you.